So believe it or not, I have been following the climate change debate, writing on it. And at one point, if you'd gone back 15
Don't tell
years.
them how long they'll realize how old you are.
Yes, exactly. Well, I started in kindergarten on this stuff, but I mean, you could kind of do the calculations. I wrote this book called The Privileged Planet with an astronomer in 2004. And so, that took about 3 years. So we were working on that in 2001. And Guillermo and I continued to speak on it. And so the stuff I want to talk to you about today, basically what I want to do is I want to try to consolidate the relevant research and literature without sort of overwhelming you with scientific details, which isn't really useful. The more useful thing is just so you can kind of get your bearings, give you 5 questions that if you can memorize them, and they're really easy to memorize, will help you sort all the stuff that comes at you through the media and through different people and through, maybe your NPR listening neighbor, or maybe you're the NPR listening person and are yourself frustrated and confused. And this issue, because, this involves things like fluid dynamics on a rotating sphere, right? So who's a specialist in that? That's a very specific thing. Who is a specialist in what's called dendrochronology? That's study of of tree rings, effectively, to figure out what was happening in past climate based upon your study of tree rings. Who's a specialist in astrobiology, which is the study of the conditions needed for life to exist on a planet. Or solar physics, right? The study of the physics of the sun. All of those things are relevant to the climate change issue. Guess how many people there are that are experts in all of those fields? Zero. That's not how science is done. Science these days is hyper specialized. And so unless someone manages to be a generalist to kind of read around the literature and have some kind of framework for discerning and filtering the good information from the bad information, you can be an amazing specialist in your narrow field, let's say dendrochronology, but know absolutely nothing beyond what the average layperson does about solar physics, right? And so, I think, so in a sense, this is why everyone's sort of scared and buffaloed about this issue, because it seems like, well, I don't know. I don't know how cloud formation and galactic cosmic rays work with the sun, And so I want you to know, actually no one's an expert in all those things. What you have is isolated experts. And this is actually part of the problem, because you have really smart scientific experts that will very often, they'll say, well, this story doesn't really make sense in my subfield, but I think that they've got all the evidence for it over here. And if you look around, it turns out that a lot of them think that. The evidence is someplace else, but it just doesn't quite work in their field. And so as a result, you can have lots of scientists that are intellectually honest and know a lot about their subfield, but they fall for kind of intellectual orthodoxies just like everyone else. And that's absolutely true here. And if you think that scientists can't fall for these sort of social hysterias, study the eugenics controversy of a century ago. The eugenics was the idea that we should, positive eugenics, which the Supreme Court in 1927 deemed to be constitutional, is the forcible sterilization of undesirable people. I'm not making that up. Buck v. Bell, 1927, and all the major scientific organizations were behind it. And that's more or less why the court ruled as it did. It's like, well, the scientists are the ones that tell us, and they tell us it's really important that we select the gene pool of our population. We don't want imbeciles, their word, right, to out-reproduce the rest of us. We want the right kind of people to reproduce, and the wrong kind of people, well, all things being equal, not to be able to reproduce. Literally, in this country, a century ago, that was the scientific consensus. You remember hearing about a consensus in 2020 about the lockdowns? There wasn't actually a consensus there. It was entirely fake, staged, managed by federal agencies and social media networks. In fact, some of the smartest epidemiologists at the time said lockdowns are absurd, have much higher cost than benefits. We all now absolutely know that. And so sometimes you can have a genuine consensus about something, like if you were to poll scientists, they would all say yes on something. It doesn't follow that they actually are all acquainted with the evidence. It may be that the consensus is a kind of something that's a social phenomenon. Or in 2020, I think we were genuinely dealing with radical censorship from the federal government, plus a kind of social hysteria. And so scientists are humans. And so if you're a layperson, you have to have some kind of way of sifting this stuff. Say, well, the smart scientists that have looked into this generally agree on it, so I'm going to trust them because I don't have time to study it. That's rational, all things being equal. None of us can be specialists in all things. In fact, most of the things we know based on testimony that hopefully is reliable. And so what you want to be able to do is say, okay, how can I tell the difference between, say, a general scientific agreement that's based on a knowledge of the evidence and a general scientific agreement that's based upon some kind of social pressure or intellectual orthodoxy? You want to be able to separate those two things out. And that's what I hope to help you do this morning. But first, let's just frame this. So I'll define all these terms, but you can't really talk that much about the science without also talking about the politics of climate change, because most of us only know about this because it's pushed as a major political agenda. So the UN, through its various agencies, has been pushing this actually for decades. In fact, what the UN does, the General Assembly, is it will establish different agencies or committees or commissions to study things. And so you've got the UN General Assembly, but then you've got the World Health Organization, right, which is the kind of public health arm of the United Nations. And so a few decades ago, the United Nations set up something called the Intergovernmental Panel on Climate Change. And the purpose of it was not to determine whether humans are affecting the climate. That was not the question that they were charged with. The question they were charged with is to determine how much effect and how bad the effect is that humans are having on the climate. That's the mandate of the IPCC. And then it issues periodic reports. And the funny thing about the periodic reports is when you study them, if you actually read the reports, even though there's a lot of problems in them from time to time, they're actually much more guarded and much more careful than the summary for media or lawmakers. And so you'll have maybe 1,000 scientists that will contribute to a report, but then, of course, knowing that most people are not going to read that report, and that the 27-year-old young woman at Huffington Post with a journalism degree from Hofstra University, I'm just going to pick on Hofstra, right, is going to be the one reporting on it. She's not going to read it, wouldn't know what she's reading if she was. And so you write a summary for lawmakers and for reporters, and an English major from Wheaton College writes that doesn't know any science, right? And that's what you get. You think I'm exaggerating. This is how this works. And so the summary will always be much more strident and catastrophist in its language than the actual report. And so an official in the Obama administration, a guy named Stephen Koonin, who's a really, really smart physicist, a few years ago got just really frustrated about this because he said politicians are constantly saying these things. Greta Thunberg is claiming we're going to destroy civilization. They claim it's based on the science. But if you just take the UN reports themselves, which are they're biased, but if you just take those, actually there's a vast amount of complexity and uncertainty in this. And he wrote a book called Unsettled. If you wanted kind of a single science book written for a general audience, it's a terrific book, came out a couple of years ago. And the critics of the book did not criticize the science. He was criticized for sharing official secrets, basically. Yes, we know this as scientists, but don't tell the public that, or they might be resistant when we make them drive electric cars. Don't say these kinds of things. And so that's the reality, is that the only reason any of us are interested in the whole debate on climate change is because it's used for political purposes. Now, that doesn't mean it's not happening. It doesn't mean that we're not causing it or it's bad. That could all be true independently. But I think we're right to be somewhat suspicious when it is used to push us to do things that we would never otherwise probably want to do. But I would say, as a Christian, we can absolutely and should accept the basic idea of stewardship. God creates man and woman. You remember, he put them in the garden. He commands them prior to the fall, be fruitful and multiply and fill the earth and subdue it. And so this is a picture of a stewardship. Stewardship is one of the only theological terms that I know of that's explicitly theological, that's actually used without controversy in environmental studies and environmental ethics. But what's a steward? A steward is a person that a king puts in charge of his realm while he's gone. So any of you that have watched The Lord of the Rings, this is how it is in Gondor, the kingdom of men. The king has left, has been gone about 3,000 years. And so for 3,000 years, there's just been a steward of Gondor. But if you go into the royal hall, that steward will not be sitting on the throne. He'll be down at the steps of the throne at the bottom, sitting in the steward's seat. That's us. God creates the world. He's the king of the universe. And then he bestows upon us this stewardly duty and responsibility, which you can summarize as be fruitful and multiply and fill the earth and subdue it. You can also think of it as God's command to Adam to till and to keep the earth. That gets fractured because of the fall, so that we're not in this, garden that just sort of does whatever we ask it to do. Instead, Adam has put at enmity with the earth so that toil and work can be frustrating. But it's not like that mandate disappeared. It's not like, oh, now the fall has happened, so we're not supposed to be fruitful and multiply. Now, that continues. But it continues in this context in which we can mess things up. So, for instance, if we detonated all the nuclear warheads on the planet, that would have an effect on the earth and life. So don't say, well, God created the world, so we can't obviously damage it. I mean, because of the fall, obviously we can. We can mess things up locally. You could dump toxic sludge in the groundwater. You could pollute a stream or a river so that it actually has, you can light it on fire on the surface. We can mess things up. So we're both stewards. The fall has happened. We can mess things up. But we can also transform things. So we're also capable, if there's a real problem, of figuring out how to fix it. So if you look at the amount of sulfur dioxide in the air or lead in the air and the water from what we had a few decades ago, it's much better. Because we realize that's probably not a good idea to have this stuff. Let's get rid of it. And so as Christians, we don't need the kind of climate hysteria to be able to say, well, yes, of course, we should be concerned about the earth. We've been placed as stewards here. For obvious reasons, we want to have clean water and clean air because we believe in human well-being. But beyond that, because we're stewards not just of our fellow human beings, but of the world as a whole. So I assume that we have reason to care about this. It's just that none of that tells us anything, right, specific about, okay, how sensitive is the atmosphere to carbon dioxide, right? You can't jump straight from God said to, till and to keep the garden, to take care of it. Therefore, we need to start driving electric cars pronto. Like, that just doesn't follow. And I can tell you the reason I did debates on this subject, including with a Time organization called the Evangelical Environmental Network, is that I sensed a kind of fake Bible washing of radical environmentalism, frankly. That it's kind of what Megan Basham writes about in her new book, Shepherds for Sale. In other words, it was basically funders, left-wing radical environmentalist funders, funding evangelical groups and pop-up evangelical groups to put a kind of biblical veneer on the agenda. And I realize, it's shameless of me, that actually these are pastors that, are have this nonprofit that is probably getting paid for by the Hewlett Foundation. And they're going to get up and they're going to make arguments like Genesis 1, therefore climate change is a catastrophe, right? And not know anything about science. So I thought, this is going to be shooting fish in a barrel. And it turns out that it was. And so this is the kind of difficulty, sort of atmosphere that we're in. And in fact, I got involved in this mainly because I got irritated about an Evangelical Environmental Network campaign called What Would Jesus Drive? So literally, I've gotten into more than one thing just because something irritated me, and I have to confess that partly it was that. So what's the implication? What would Jesus drive? And it was a picture, they had a big picture of a van with, those vans that have like 6 rows, and you've got the back that sticks out like this. The idea was that, Jesus wouldn't drive one of those. I guess drive a Prius or take the bus or something. But it's like, well, what if Jesus is traveling with the disciples? I mean, that's 13, right? Or what if you're a homeschooled mom? That it's way more efficient to have one of those vans. I mean, it's just completely absurd, right? Because what they're trying to do is it's a kind of buried premise in the question that the implication is that, of course, Jesus would drive the most fuel-efficient small car possible, which is ridiculous. He would presumably make calculations like the rest of us based upon what he wanted to use the car for. right? They didn't want you doing that. They just wanted you, to feel guilty because your car was slightly too large. But so, for instance, the parking lot, I guarantee you outside, has much larger cars than the parking garage at the Heritage Foundation, which is in downtown DC. Now, is that because Montanans don't care as much about the environment as Washingtonians? Of course not. It's because Montanans do different things for which they need trucks. Having a large, giant Ram truck in Washington, D.C. means you're never parking in a parking garage the rest of your life, right? So you're just not going to do that. And so we all drive much smaller cars than we probably would if we lived somewhere else, including me. So that's all kind of backdrop. So in the first part this morning, I want to help you understand the basic claim of climate change, and then we will talk about the 5 questions, all right? So here's the basic claim of climate change. It's not that the climate changes, of course, because that's a truism. So that can't quite be what the claim is. But this is essentially it. One, not just that there's change, but that there's global warming. So in other words, the average temperature of the Earth's surface is going up over time. And you might say, since when? Which is an obvious question, but just take the generic sort of point here from the beginning. So the average global temperature is going up. 2, that's catastrophic. In other words, it's a really bad thing that we should be concerned about. And 3, that it's induced by humans. It's human induced. And it's that third one that is absolutely crucial, because if the first 2 are happening, okay, there's warming of the planet, it's catastrophic, and the reason is that the sun is about to use up its fuel and become a red giant or something, right? Or the sun is giving off too much energy now. There's no political agenda there, right? What are we going to do about that? Well, we would try to adjust and adapt. It's the claim that it's human-induced plus catastrophic that makes it really salient politically. Now, most of us don't really kind of know the details of this. What we know is sort of third-hand reports of this from magazine covers. In fact, it turns out, this is a sort of depressing reality. You bringing me some water? Thanks. That most people don't even read the articles in biased news. They just read the headlines, right? So most of us actually get most of our information from the headlines of biased news stories of biased studies, right? It's amazing we know as much as we do. And so this is a cover from some years back, and I especially like it because it says, "Be worried, be very worried. Climate change isn't some vague future problem. It's already damaging the planet at an alarming pace. Earth at the tipping point." Now, this is already almost a couple of decades ago, but I want you to see the picture. Okay, so what are you supposed to think about this picture? You don't actually have any details about it, right? But notice how the message frames the picture. And so the mental image you have automatically is that, okay, well, that's a polar bear, obviously. He's on a little piece of ice. There's a bunch of water around him. And I guess he's about to drown, right? Because we're melting the ice caps, or in this case, the northern ice cap. That's what you're supposed to think. What do you think he's probably doing now that I've raised your consciousness to this? He's waiting for a seal to come up for air, obviously. And there's a number of examples of these stories of the photographers who took pictures like this, and not this one, but other ones on a little iceberg. It turns out they were taking pictures of the polar bears because the polar bears were climbing up on the iceberg and jumping in like it was an amusement park. They took a picture, and then it got used for these kinds of things. All right? And if you're old enough to remember, if you're at least a Gen Xer, you can remember, as I can, when I was a little kid in the 1970s, that the official consensus view, we were told, of scientists in the 70s was that we were due for another ice age. And what was funny is that if you read the literature at the time, you can just Google this stuff from the 70s, it would say scientists generally agree. So when you get these sort of pronouncements that scientists agree, okay, so you'd assume, okay, there must have been some years where they were debating. Maybe I can find news stories about that. And then they debated, and fewer and fewer debate, and they all come to agreement. But when suddenly the first time you've heard of the story is the moment that you're also told that all the scientists basically agree. That's a little suspicious, isn't it? It shouldn't be how a rational consensus works. And so this was, of course, the global warming is from the last couple of decades, the 2 time covers for the 1970s. And then this was a very popular book at the time called The Weather Conspiracy, The Coming of the New Ice Age. And so there was a genuine worry. It wasn't irrational. And the reason is because there was a cooling trend from the 1940s to the 1970s. And if you sort of look at ice cores and records of the past, worrying about, if you're going to say what's more worrisome, that it be 1 or 2 degrees warmer on average, or that it be 8 or 10 degrees colder and most of the planet is covered in a couple of miles of ice. I'm worrying about the second scenario, right? And so there was a reason to worry about this, but these can't both be true. We can't be both just about to enter a new ice age and also be catastrophically heating the climate. Or if somebody tries to tell you both those things, you can be a little suspicious. So this is one of the ways I think when you're using your critical faculties, you say, well, have opposite positions been defended by some of the same people over a fairly recent time period for the same reasons? And in all cases, they appeal immediately to a consensus that maybe there's a little bit more going on. But the Ice Age story is not, at least at the moment, the popular story. Instead, we've got anthropogenic global warming. So anthropogenic just means human caused. And so if you see that word or you see AGW, that's just human caused global warming. All right, and it's a really basic claim based on some fairly straightforward physics, all right, and some observations. So here's the first sort of premise of the argument. During the 20th century, industrialization caused a rapid rise in carbon dioxide, which is a greenhouse gas. Now, greenhouse gas, these are a number of gases that, at least obviously in their gas forms, are 3 atom molecules. And for complicated sort of reasons of chemistry and physics, they have the capacity, think of it, they get excited by certain wavelengths of radiation and become more energetic. But a simple way to think of it is that these greenhouse gases can trap heat that might otherwise escape back into space. All right, and so this is an uncontroversial point that various kinds of greenhouse gases, including CO2, function in this way. Now, it's not literally like a greenhouse, because a greenhouse works by sealing off the air, and then you let energy go in, and it heats up because it's sealed off. In this case, there's not a seal around the surface of the Earth. We've got an atmosphere that's, doesn't have a top to it. But it works like a greenhouse in the sense that it's warmer than it would otherwise be without those things. That makes sense. All right, and this is not. There's no controversy here that industrialization, in fact, there's a perfect correlation between increases in carbon dioxide in the atmosphere and industrialization. Okay, so second, as a result, global temperatures have risen to unprecedented levels. Now we're getting an argument, or at least an assertion, or at least a hypothesis. This could have said global temperatures have risen, period. It could say global temperatures have risen to unprecedented levels, right? So that's something you want to investigate. But this is, as a result, global temperatures have risen to unprecedented levels. So already in that second sentence, you've got basically 3 arguments, right? One, that the reason for the warming is because of the increase in CO2, and that the warming is unprecedented. Though those are claims you can go to check with the evidence, all right? And then 3, this global warming will have catastrophic effects on the climate. So you get the ideas. We add carbon dioxide to the atmosphere because of industrialization, right? That raises the temperature of the surface of the Earth to unprecedented levels. So in other words, much higher than you would expect naturally or that's happened in the past, something like that. And it's going to have catastrophic climate effects. So it's not just it's going to be a little warmer and a little balmier. It's that it's going to lead to severe droughts. It's going to lead to much more flooding than you would otherwise expect, more intense hurricanes, more intense tornadoes, all that kind of stuff. So that's the idea, right? The theory predicts is that as you do this, you're going to lead to all these bad things, not just that it's going to make it a little bit warmer. All right, so that's why it's called climate change rather than just global warming, because it's changing it, and it's changing it in a way that's bad. All right, all of that's absolutely crucial. All right, so every one of the great thing is that every one of those claims can be compared with the evidence. Evidence, believe it or not, if you know what you're doing, you can actually just find online. This is not hidden in a vault somewhere. It's not at the NSA. It's not hidden in the CIA. It's out there. Trust me. Now, I can tell you that Google tries to keep you from finding it easily, so you do have to kind of know where to go. All right, so a few details about this. So here's, if you're wondering, okay, what determines the temperature of the surface of the Earth? First guess. If you had to say one thing that determines the temperature of the surface of the Earth, what would you say? The sun. Man, yeah, that yellow dwarf up there in the sky, right? That has an effect on the sun. What you might not know is if there were no atmosphere, the Earth would be much, much colder than it is otherwise, despite the energy from the sun. Right? Mars, which is just a little farther away than we are, but has a very thin atmosphere, right, is very cold. The moon, which, right, it's right around the sun, so it's basically the same distance on average as the Earth, is extremely cold on the surface. Why? Because it doesn't have an atmosphere. So the greenhouse effect is absolutely crucial to life on the surface of the planet. And the way this happens, it's sort of determined by three things. So the intensity of sunlight, or the intensity of the energy that's coming from the sun, which can be the result of the sun giving off more or less energy, or it can be the result of us being closer or farther away, right? What's called the albedo, and all the albedo is how much energy does a surface absorb versus how much does it reflect back into space, all right? And so it can do either thing, and different surfaces are more absorbent than others. And then there's the third thing is this greenhouse effect, in which you have compounds and elements in the atmosphere of the planet that can increase the temperature by holding in more of the energy than would otherwise be around if it was just the kind of reflective properties of the surface. Okay, so intensity of sunlight. Now, so the sun does vary in its luminosity, and we have these sunspot cycles, and so it does actually vary a little bit over short and long periods of time, so that has kind of some effect. And so everything I'm telling you here is uncontroversial. And then, as I mentioned, the distance from the sun itself, even though the Earth is almost perfectly circular in its orbit, it is slightly elliptical. In other words, slightly oval-shaped. And so as a result, we're sometimes closer to the sun at a couple of points during the year than at other points. We vary slightly in our distance from the sun, and that has an effect. And then, of course, we know this locally. We're acutely aware of it, the fact that we have, because of seasons. So that's the result of the Earth's tilt on its axis, so that depending on where the sun is in its orbit around the sun, we might get more or less light in our area. So you guys know this. And then, as I said, the albedo is just the fraction of light reflected off of a surface from 0 to 1. So the average albedo of the Earth is 0.3, so that means that it absorbs about 70% of the sunlight. Now that's the average. Now why do I say it's the average? Because the Earth isn't perfectly uniform. It's not like the moon, and it's not like, say, a water world. We've got water, we've got liquid water in the form of ice, we've got land. Land is sometimes green, sometimes brown, right? We've got snow, and we have clouds. All of those reflect sunlight differently. So low albedo is the oceans, right? Medium albedo is continent or lands. And then high albedo is the ice and the clouds. All right, and what's funny about this is that we've known this, the gist of this, since at least 1911. So here's a science paper, you don't need to read the fine print, discussing this and getting it more or less right way back in 1911. So that's how long we've understood the basics of this, since 1911. The key thing is that clouds generally have very high albedo. Albedo is very close to the word libido, and I'm always afraid I'm going to say that. And now that I've said it, I probably will. I've never made that mistake, but I'm always thinking albedo. Albedo. All right. There's a whole rabbit trail we can follow there, isn't there? All right, so you get the basic idea. But here's the thing, is that what changes most dramatically over the short time periods? Does the ice caps, do those change over the course of hours? No. Do the oceans change over the course of hours? Do the shape of the continents change over hours? No. Clouds, though, cloud cover changes dramatically over time, and different kinds of clouds have different albedos. And so even though we've known the gist of this since 1911, the effect of clouds on all this stuff is still not well understood. And that's, in fact, where I think almost all the action and the controversy comes down to. So the greenhouse effect is this. This is a kind of simplification. So you got energy coming in from the sun. Some of it's absorbed by the surface of the earth. Some of it is reflected back in the infrared. And then some of that ends up back out in space. And some of it stays on the surface because of the presence of these greenhouse gases. And so makes the surface warmer than it would otherwise be. And then because of basic principles of thermodynamics, the energy ultimately is going to have to balance out. So the total amount of energy is ultimately going to have to be equivalent to the amount of energy either absorbed or reflected, right? And so you can imagine that if there's more energy coming in, that you're going to likely have more energy that needs to either come out or that's going to get absorbed and increase the temperature of the planet, right? So that's fairly straightforward stuff. All right, so let's talk about the greenhouse gases themselves. Don't worry about that complicated figure. I just wanted to kind of show it to you. So top 3 greenhouse gases in order: water and water vapor. By far the most important greenhouse gas. So remember what a water molecule is? H2O. So remember what I told you a minute ago? 3 atoms. Molecule has 3 atoms. So it is the most important greenhouse gas, in part because it's condensable. So we can have it in the gas form, we can have it in the liquid form, we can have it in the solid form. And in fact, it's probably at least 20 times more important as a greenhouse gas than any of the others that you ever hear about. All right, so that's 0.8% of the atmosphere on average. Second would be carbon dioxide. Now, carbon dioxide at the moment is 0.04% of the atmosphere, so roughly 400 parts per million. So it's basically a trace element in the atmosphere. All right, and then that's what everyone focuses on. Remember that. They don't focus on the water vapor, which is huge. They focus on the carbon dioxide. And then methane, which is a much, much smaller part of the atmosphere. And there's some others, like nitrous oxide. So basically any 3-atom molecule that's floating around in the atmosphere is going to have some kind of energy absorbing characteristics. All right, so you can see how, like, initially, okay, so if that's true, I don't know anything else, and then we add more CO2 than there was before, all things being equal, you would expect maybe the surface of the Earth is going to be warmer because of the CO2. Right? So you can see how that's, what I've given you is that's kind of the surface level. That's about how far people get in their thinking. And I can tell you, studying kind of the Christian space on this, that is about like where the pastor that has spent all his time studying this, and he's, the Sierra Club has taken him on tours of the Great Barrier Reef and stuff like that. I'm giving you the level he knows. Oh, CO2 is a greenhouse gas. We've added CO2, so it must be warmer. And I've heard that that's bad. That's just it, right? So that's how, if you want to debate the issue, you're up to speed, right? You're almost never going to get any more details than that. All right? All right, so that's the entire background. So industrialization, we've gone from roughly 200 parts per million to now I think it's about 415 parts per million of carbon dioxide in the atmosphere. And so the claim is that 200 and some odd parts per million, let's assume we have added all of that. We don't know for sure, but let's just assume that slight increase in this trace gas, that's a greenhouse gas, is going to lead and is leading to catastrophe so profound that we have to completely restructure the global economy and global energy use to avoid catastrophe. That is the claim. All right, now so intuitively that'd say, okay, well, the evidence better be really, really good if we're going to have to do that, especially since there's a lot of people still in the world that still don't have basic access to energy. All right? Now, I'm tempted to stop and take questions right then, but I won't. That's the background. So what are the 5 questions? Now you're prepared. Here are the 5 questions. If you forget everything else, I hope you'll remember these. And we'll go through them one at a time. First, is the Earth warming? Just the basic question, is the evidence strong that the first claim is true? 2, are we causing it? It could be warming. You say, yeah, it is warming, but whether we're causing it is a secondary question. Right? The causal question is different from the question of whether something's happening. Third, is it bad? That's a simple way to think of it. And you can separate that out into, is it bad that CO2 is increasing? And is the warming itself bad? Assuming those are connected. They're actually separate questions. So I've hidden two questions in one question, I know. And then, what should we do instead? In fact, let's separate those, the other two. What should we do instead? Oh, I'm sorry, I skipped one. So, is it bad? Number 4, would the advised policies make any difference? That's 4. And then 5, what should we do instead? Now, you can tell from that question that I think the advised policies are really, really stupid. And I think I'll substantiate that later. But if they were good, we wouldn't say, what should we do instead? All right, so is it happening? Are we causing it? Is it bad? Would the policies, even if yes, yes, and yes to the first 3, make any difference? And if not, what should we do instead? Those are the 5 questions. All right, we can do the Earth warming part really, really quickly. So Dick, we want to take a break right at 10. Is that how we normally do this? Okay. I'll just read the body language. I know what it looks like if somebody really needs to go to the bathroom, because I know what I do and I really need to go to the bathroom. It's like, come on. All right, so long story short, we seem to be in a gradual warming trend since 1850. Now there's lots of scatter and uncertainty, but we have historical records of different kind of weather things. We have historical records of people talking about, what the summers are like and what the winters are like. We have surface measurements of thermometers. That it gets complicated because if you have a thermometer and you're checking the temperature and it's accurate, and it starts out in a field and then it ends up in the middle of a parking lot in the middle of a city, it's going to be warmer, right? And so then you have to take account of that in order to have the accurate measurements. And then you can do other things in terms of analyzing ice cores and tree rings. There's a bunch of different ways of kind of getting at this data. And then starting in 1979, we have satellites that can measure the average global temperature from space. And so those are really precise, but we've only had them since the 1970s. And so this is 2 different data sets. So the Hadley Center for Climate Change in the UK and the Goddard Institute for Space Studies and National Climate Data Center. That's the red line. All right, so these are independent of each other, and they show more or less the same thing. Now look at the scale, though. The temperature anomaly means variation in temperature. The scales are 0.2 of 1 degree, right? And so over that period, if you start in 1850, it looks like we had a warming trend of about 0.8 degrees centigrade or Celsius, or about 1.5 degrees Fahrenheit. So if this is right, it's about 1.5 degrees Fahrenheit warmer on average on Earth now than it was in 1850, on average. So it doesn't mean that every place is warmer, right? It's sort of it's the average of the whole surface. All right, so that's sort of interesting, right? It doesn't tell you very much at all. Now this is the image from the 2001 UN report, and it was famous because it put this image on the surface based upon the research of a guy named Michael Mann, who is a dendrochronologist, and so his expertise is studying tree rings, in which he claimed to show that there was this sort of catastrophic increase above the natural variation. So you'll notice on this graph, you get kind of natural variation, and then right at the end, it looks like it's really going crazy, right? That's the stuff in red. That looks really, really scary. And so this is where the claim that it was unprecedented came from. 2001 UN report, all right? And this is called the hockey stick, graph, right? Because you see how it looks kind of like a hockey stick. So the idea is this is what sort of normally happens, and then all of a sudden, we've got this unprecedented spike. Now, anybody know what happened to that diagram in the next report? Bye-bye, disappeared. Unceremoniously, no explanation. If you look into it, it turns out Mann was very careful about selecting which tree rings that he counted for his study. And almost certainly, either intentionally or unintentionally, cherry-picked it. So it not only was not in the cover of the next report, they just sort of ignored it. Now, what are you noticing? There's a bunch of stuff to notice. This is from 1000 AD to the present. So the time scale is 1,000 years, right? Don't you kind of wonder what this would look like if we spread it out a little bit? So here's also, and this is, by the way, general consensus, and also the assessment report. This is an average of the global temperature going back 1,000 years looked at differently. What do you notice? So this is the averaging out of it. I'll show you the technical graph in a minute. What you will notice is there's a period called the medieval warming period at about 1000 AD, in which it was at least as warm, if not warmer, than it is now. Now, you never know much about this, and we learned in 2009 when all these emails of these guys like Michael Mann were leaked, that a lot of their model reconstructions were designed specifically to hide this. They wanted to disappear the medieval warming period. The problem is there's way too much data for it. But they knew that this would be an embarrassment if somebody looked at this and said, well, that's kind of weird, but you're saying it's unprecedented, but it looks kind of like this, less bad than it was in 1000 AD, right? So here it is, because of course the data is sort of more variable. And this goes 2,000 years back. So now you'll notice there have been two warming periods in the northern hemisphere. One around the time of Christ, called the Roman warming period, and one called the medieval warming period. And then look at where we are. The modern warming period, that green line is when we started having surface temperature measurements, and then the little blue dash there, that's when we started getting satellites. All right, so and then the dark black line is kind of the average of these things. So you can see what happens is the second you expand the scale to 1,000 or 2,000 years, all of a sudden the warming we're having now is utterly unremarkable. It's just not significant. And so by itself, the fact that there's a warming trend since, say, 1850, with a temporary cooling trend from the 40s to 70s, doesn't really tell you very much. It certainly doesn't tell you, there's no reason to think it's bad. You know, humans lived during the Middle Ages. Not that complicated, all right? So let's just assume that it's a slight warming trend. Are we causing it? That's a second question, right? So you could have really good evidence that the Earth is warming, but you could have evidence that the Earth's really significantly warming, so much that what Al Gore claimed by 2015 that the Arctic would be ice-free, which didn't happen. None of these predictions ever go right. But even if that were true, even if that had happened, that would not tell you if we caused it, right? We'd need some other kind of evidence that we're causing it. Now, there is here's the kind of uncontroversial part of the discussion, is that carbon dioxide is rising in the atmosphere in terms of its sort of total concentration. So this is the data from 1960 to, I'm sorry, it stops at 1920. And then you've got a dashed line. And the reason for that is that the ocean, when it's colder, can hold more carbon dioxide than when it's warmer. And so there's seasonal fluctuation in the amount of CO2 in the atmosphere and the hemispheres. This data is from the Mauna Loa Observatory in Hawaii, where we have a detector. And you got it. So why would that be? If you're going to measure, like you can only pick one place to measure the average carbon dioxide in the atmosphere, where are you going to do it? Are you going to do it in New York City? Or are you going to do it in your garage? Right? No. You'd want it to be someplace where you suspect, okay, the air is mixing pretty well. And so the best place to do that would be some dry place in the middle of the Pacific Ocean up high. And that's what we have with the Mauna Loa Observatory. And you'll notice, so we've gone from about 320 parts per million to, let's say 420 parts per million in the present, right? So that's going up. It doesn't tell you for sure that humans are the complete contributor to that. I suspect it's probably a mix, but let's just say that we're doing 100% of that, all right? That's still actually, in terms of the actual concentration, notice we're still dealing with parts per million. So very insignificant sort of total amount. All right, so but does it follow that CO2 is the main driver of global temperature? Now, to really answer this question, you've got to look sort of way back in the distant past and look at all of our sort of data on temperature and things like that, which can be done. The answer is almost certainly no. Yes, it's a carbon dioxide, or yes, it's a greenhouse gas. Yes, we've added it. So in principle, it can make the planet a little warmer, but there's no reason to think that it's actually the main driver of this. Now, why do we say that? Well, for instance, the ways in which we're counting the effects of the warming, things like glacial recession. So if you ever take a cruise to Alaska, my family and I did it from Seattle one time a few years ago when we lived in Seattle. It's amazing, by the way. But you'll go into, you see one of these glaciers, and the guide will tell you how terrible it is that this glacier is receding, and then they will take you all the way in so you can see chunks of ice. And you're supposed to both think, wow, this is cool, but also it's terrible at the same time. It's really mentally dissonant, kind of. Oh no, and you're going into a fjord, basically, right, with these amounts that you can only get into because the glaciers are receding, but that's all bad, right? It's terrible. But it turns out this has been happening for a long time. So this is from the Mendenhall Glacier that some of you maybe have seen in Alaska. This is a 1,000-year-old tree stump from a medieval forest that was exposed from a receding glacier, which 1,000 years ago was growing trees. So what does that tell you? That it's receded back to the level it was 1,000 years ago. So, not that significant. This is the Hvalsey Church in southern Greenland. So if you've ever wondered, there's a country called Iceland and there's a country called Greenland. And if you've ever flown over Greenland, I've done this several times and it was clear, it's not very green. It's almost entirely encased in ice, though in the very middle of the island or the landmass, you'll see these beautiful little lakes in the summer on top of the glaciers that humans have probably never seen. But the Vikings settled southern Greenland around 1000 AD, built churches, called it Greenland. Now, there's some dispute about whether it was really green or if that was marketing back home to get people to leave. Oh yeah, this is Iceland. This is not pleasant. Go a little farther west, there's a Greenland. Go there. So there's some debate, but we know it was at least green enough that it sustained people for a while. But then it mostly fell apart. This was not a major settlement. Iceland is a country. Greenland, is, there are a few thousand people that live there. But what happened? Well, what happened was the Little Ice Age around 1700, in which the temperature was much, much cooler. All right, so we think they disappeared probably at sometime in the 1400s. Here's the other thing. If you're saying, okay, so CO2 is a real driver of the climate, then you would expect that when we get data of past climate, what you would expect would be that when CO2 goes, because the amount of CO2 in the atmosphere, by the way, varies dramatically over long periods of time. Very, very dramatically. And so if the atmosphere was really sensitive to the amount of CO2, what you would expect is that when we look at data from the distant past, that if CO2 goes up a little bit, it gets much, much warmer. The CO2 goes up a little, it gets much, much warmer, and vice versa. And in fact, if any of you saw An Inconvenient Truth with Al Gore, he claimed this. He had a map and he showed, based on ice cores. So ice cores, we have two good sets of ice cores, one in Greenland and one in Lake Vostok in Antarctica. And so the idea is that you just literally dig a core of ice, and you think of this as like tree rings, but it's ice layers. And you can see the 11-year sunspot cycles in the ice layers based on a variation in the ratio of isotopes that are in the atmosphere. And so you can sort of map it, and based on other isotopes, you can, in a complicated way, comparing other things, including data from stalagmites, believe it or not, kind of reconstruct the amount of carbon dioxide in the atmosphere on average and the temperature at the time. Now, when Al Gore showed this, what he showed is the carbon dioxide going up and down. And so there's a complicated pattern. And then he overlaid the temperature readings, and they matched perfectly. So his argument was that the increase in CO2 is leading to temperature increases. This was so bad that the New York Times had to correct him on a Science Tuesday, because it turns out there's an 800-year lag in the data. So in other words, what happens is that the temperature would go up, and 700 or 800 years later, CO2 would go up. And then it'd get cooler, and 700 or 800 years later, the CO2 goes down. Now, what does that tell you? Well, it tells you something you already know, which is that when it's colder, the oceans can hold more CO2 than when it's warmer. But it also tells you that the warming and the cooling is happening for some reason that's sort of not connected to CO2. It's not at all what you'd expect. And so Gore literally shifted the sequence of these two things to make you think it was the CO2 causing the temperature increase, when in fact it was the temperature increase causing the increase in CO2. That bad. That bad. So I could bore you to tears on the ice cores, but that's the kind of general gist. So what you see here is a really nice kind of correlation of temperature and carbon dioxide. It's just that the temperature change comes first and then the carbon dioxide second. All right, and then finally, so if we know CO2 is a greenhouse gas, but we now also know that, well, it can't be that sensitive to CO2 because of sort of past studies of these things. In fact, there's times in the distant past, if we're right, that had far, far more carbon dioxide in the atmosphere than we did now. But this is the kind of kicker, is that it turns out that as you add more and more greenhouse gases to the atmosphere, it makes less and less difference. So it has diminishing marginal returns. Think of it this way, like painting a barn red. So if you paint a barn red with a really good paint, it's going to look red, right? Now you might add a coat. So now you add a second coat. And you'll notice that the change from the brown to the red is not as significant as the change from the red to the thicker red. And if you add a third coat, you're spending money and your eyes aren't going to be able to tell the difference. So do you get the idea? So with painting, there are very quick diminishing marginal returns. In other words, the effect becomes less and less significant. It's the same thing with greenhouse gases. It's a sort of complicated story that I could explain to you here. This is the figure, in case somebody wants it, you can take a picture of this. This is from Will Happer, a physicist at Princeton. But it basically shows the different greenhouse gases and where their capacity sort of is optimized. So at what wavelength do they absorb more of the heating radiation that's reflecting off the Earth? And then, so what happens, the simple way to think of it is that it eventually gets absorbed so that it just can't capture any more heat. And so what that means is that the warming effects of CO2 are greatest from 0 to 400 parts per million. And so the most effect that CO2 is going to have has already happened. And so if we're going to have any sort of future effects, we're going to have to keep doubling it. So what's likely is that there's maybe an increase of about 1 to 2 degrees that first time, and then 1 degree for every doubling of it after that. You hear what I'm saying? So not adding 1 part per million, but doubling the amount of atmosphere, of CO2 in the atmosphere. This is where the entire debate is right here. And this is well known and well understood. I had been in debates with Christian scientists about this. In fact, I did this in 2015 at my school where I was teaching at the time. I won't name the guy, and I pointed this out. I said, look, you know, based upon our knowledge of the physics of this, that most of the warming effect of CO2 is already behind us, and that you're going to get a much diminishing return. So why would we fixate on this? And you know what he said? He implied that I was being funded by an oil company to say that. I am not making this up. And I was really mad because I wasn't being funded by an oil company, despite really trying. No, I mean, that was literally the argument. All right, so this is the absolute crucial point, is that there are diminishing marginal returns. We don't know exactly what it is as we continue, but you get to where we are now, right? And we're already at the point where it's not going to make much difference. Now, you might wonder, so why are they predicting such catastrophe? We'll talk about that in a minute, but why don't we take a break there? Oh, not so fast? Not allowed? Okay.
There are a couple of books up there.
Oh, I'm so sorry. Yes.
You are vaguely familiar.
Yeah, I'm sorry. So Dick wants me to.
I'm considering buying those.
Okay. What are they about? Okay, so Privileged Planet, 20th year rewritten and revised anniversary edition. Talked about this last night. You can. In fact, it's much more understandable than the one from 2004, actually, I would say. And it has over 100 illustrations and 20 pages of color illustrations as well. So, but it's, you know, if you're into science, it's written at a popular level, but it's definitely a science book. And then Fight the Good Fight, which I wrote with James Robinson that came out this year, is my best attempt to distill all of the main political issues that we have to deal with, and to think, okay, how do we understand this issue as Christians? And then how do we make the case for these things in the public square for people that don't share our faith? And to do it in 60,000 words, because that was the publisher's limit. They made me cut it back to 60,000. So this was actually really easy to read. There's a whole chapter on climate change.
By the way, I have reviewed that. He just talked about No, I have to talk to you about all the human rights. Awesome. And if you are interested in Dr. Hackett coming in November, there are some of these over by the books as well. You're dismissed for 10 minutes, and then we will harass you again.
What time is the service tomorrow we were speaking?
All three. I forget if it's 8 or 8:30. I think it's 8, 9:30, and 11. It's whatever the regular service